Okay, moving into the GUI and Graph Visualization. Before that, let me introduce myself. I am Nurhumara binti Jeffrey. For this part, we will explore how the graph and the GUI elements work together to visualize the relationship between the pressure drop and flow rate in pipe system. Now let's take a look at the GUI interface. Here on the left, we have several input fields that control key parameters of our system. First we have is pipe diameter. This field allows us to specify the diameter of the pipe. The larger the diameter, the less resistance the fluid will face. For this, I will set it to 0.05 meters. And then up next, we have pipe length. This field defines how long the pipe is. A longer pipe typically results in a high pressure drop. For this, I will set it to 10 meters. And then we have fluid viscosity. This measures the fluid's resistance to flow. A higher viscosity means the fluid flows more slowly and encounter more resistance. For this, I will put it 0.001 Pascal second. And then next we have the fluid density, which defines the mass per unit volume of the fluid. A higher density fluid will experience a higher pressure drop at the same flow rate. I will set this to 1000 kilogram per cubic meter, which is typically for water. And now this is the flow rate slider. As you can see, as we slide it, it will change value. But for this simulation, I will set it to 0.05. Okay, now we press the run simulation. Here we have the pressure flow rate relationship graph. The x-axis represents the flow rate and the y-axis represents the pressure drop. As the flow rate increases, the pressure drop increases as well. So the graph demonstrates how these two quantities are related. At lower flow rates, you will notice that the pressure drop increases gradually, which typically indicates laminar flow. At high flow rates, the graph steepens, showing that the flow might transition to turbulent flow, where the pressure drop increases more rapidly. That's all for this part.